Start with the relations part today. Page number 14. Start with the relations. So last class we had seen how to find Cartesian product. Cartesian product means, when given two sets, you have to find a pair, like one element at a time. So now we'll see what is a relation. As per the definition, a relation is a subset of A cross B. It is a smaller part of the Cartesian product. This is what it says. R is subset or it can be equal to. This is what a relation. So I'll explain to you what exactly it means with the help of an example. Like there only you can see a fruit set A, what is given? A fruit, a vegetable, and a spice. Okay. And B is given as some fruits and vegetables are given mixed up. Okay. Now, suppose if we had to find a Cartesian product, how you would find? It would be fruit comma orange, fruit comma pepper, fruit comma carrot, fruit and apple. Then veg and orange, veg. So Cartesian product does not see whether they are related or not. Cartesian product is in general. He will find a pair with every person or everything. Okay. Now, relation is like a specific condition. So what it would be, like fruit will go to the fruits only. If we had to draw an arrow diagram, we'll see the arrow diagrams in detail next. Vegetable will go to carrot and spice. So it is like only to the specific arrow, this terms, the arrows will go. Cartesian product, fruit would have arrows to everybody. Veg would have arrows to everybody. Like, so this is the difference. Cartesian is in general, and relation is with the condition, with some specific terms. Now the actual example we'll see on page number 15, which is there. So we'll try this one now. A is given 1, 2, and 3. B is given as 2 and 3. So for this particular, just find what is the Cartesian product first. In general, just find a Cartesian product. You know that Cartesian product doesn't need any condition. Only you need set A and set B, and directly you can find it. So find a Cartesian product for this. So this is the Cartesian product. Now they have given some relation. Not necessary every time it will be the same relation. The relations can change. Now in the question they have given this. Suppose A come B. A belongs to, that this is A, this is B. So A belongs to the capital A, B belongs to the capital B, and A is equals to B. So this relation we have to find out of the Cartesian product where A is equals to B. So we have to pick only those pairs where A is equals to B. So you cannot take this because A is less than this. So this one and this. So this is the relation. So R will be what? 2, 2 and 3. So this is a specific relation where A and B are related. So you can tell A is equals to B. Pick only those pairs where A is equals to B. Anything they could have given. If it was A is less than B, then we have to pick those pairs A is less. So this is not fixed. This condition can change as per your question. So this is one example of one of the relations like that. So Cartesian product. If you see, is this a subset of Cartesian product, R will always be a smaller part of the Cartesian product as per the definition. So A is equal to. Clear? Okay. Now we have to know how to find something called as three terms. We'll have to know: domain, range, and codomain. These are the important ones. Domain, range, and codomain. Given the arrow diagram, find range, domain, and codomain. So this is given. So this is like a question. And then will come the solution. So this is called as the arrow diagram. Okay. A set is, now they have given, I have not framed this. In general, they have given. So this is the arrow diagram given. Now we have to find a relation out of the arrow diagram. The solution, first we'll find a relation also. Although it is not asked, still you can write the relation. So only the ones which are having arrows, they are related to each other. B has no relation with anybody. Same way 3 has no relation with anybody from A. So that is why they are left out. So while writing the relation, A is connected to 1, C is connected to 2, and D is connected to 4. So this is how we write the relation out of the arrow diagram. Only where the arrows are going, only those pairs you have to take. Now, domain is always on the left hand side. Input. So this is like an input, this is like out. This side is always range. Okay. Or even sometimes it is called pre-image. Or it is called as image. Image or range. Both terms mean the same thing. So now we have to take only those elements from the left hand side. So that is your domain. Domain is nothing but all the elements who are there in set A, or directly you can look over here. All the A elements. So A, comma, C, comma, D. You have to write like this with a comma and close it with a curly bracket. You have to write it in the set form. So all those elements from set A who are having some relation with set B. So A is having, C is having, and D. B we cannot take. So looking at the arrow diagram, A, C, and D, suppose arrow diagram was not given and only relation was given, A, C, and D, first elements. Range is the second ones. 1, 2, and 4. 3 we cannot take because it has no relation. So anytime you forget how to write domain range, you can come back and look at this example, you will understand. And then codomain. Codomain has nothing to do with anything. You have to write entire set B as it is. Or you can say full set B in simple words. Irrespective what, who is connected, whom doesn't matter. The entire set B is called as a codomain. Domain is basically like the input, range is like the output. So now based on this, we'll start solving the exercise. We'll look at the first question and try to answer. Set A is given, set B is given, and the relation is given to us. Anyone having difficulty in domain, range, codomain? Now we'll draw the arrow diagram. So draw set A, entire set A, and put all the elements of set A in the arrow diagram. And now connect. 1 is connected to 3. 1 is also connected to 6. 3 is connected to 6. And 5 is connected to something in this stuff. 3 is connected to 3. Okay. This I was. Okay. Now this is the arrow diagram. Next you write the domain. Domain, no need to check arrow diagram and get confused. Directly look at the first elements. Domain always is here, the first elements. When you go to write domain, 1 is already written, so don't write it again. Next now. Already written, then don't write. So this becomes a domain. All the first elements. So it's from 1 arrow is going, from 3 arrow is going, and from 5 arrow is going. So that becomes a domain. Range all the second elements. 3, 4, and 6. Or 3, 6, and 4, whichever. Doesn't matter. Order does not matter. And codomain will be entire set B. This is how the question can come. Then second one, first question, any difficulty in this? Given the relation, this is how we draw arrow diagrams, domain, range. Something is wrong? Huh? Keep going. This one, arrow diagram. You have to look over here. This is from A, this is from B. 1 is going to 3. Then 1 is also going to 6. Then 3 is going to 3. 3 is going to 6. And then last 5 is going to 4. So this is always A and this is always. Then domain, you understood how to take? Domain are all the first set A elements which are having the arrow. Okay. Now we'll see the second one. Which of the following are relations from A to B? So as per the definition, what is the definition? It should always be a subset or equals to A cross. This is as per your definition. So first let us find a Cartesian product. So 1, 4. So now check with the definition. Either you can use definition wise or you can use arrow diagram wise also. But arrow diagram will take time if the numbers were more. So drawing that arrow diagram every time will make up this. So you can check like this also. 1, 2, 3, 4, 5, 6. 1 is going to 4. 1 is going to 5. 1 is going to 6. Means all the arrows should go from A to B. No arrow should come ulta. That means it is a relation. This is using arrow diagram. And using definition, if you want to check, only directly you can check from there. Is 1, 4 a part of this? Yes. 1, 5? Yes. 1, 6? Yes. So R1 is a subset of A cross B. Therefore, relation. This is definition. So this is easier rather than drawing arrow diagram every time and check. Same way, now check the second one. Just you have to see whether the elements are there in the Cartesian product. If yes, all the elements should be there. If yes, then it is a relation. If even one element is not there in the main Cartesian product, then it is not a subset. And it will be not a relation. Check the second one. First one, this is the relation given. We have to check whether it is relation or not. So we have to just check whether it is a part. Yes, it is there. So it is a subset. Second one. So just check. 1, 4, yes. 2, 6 is there. 2, 4 is also there. 3, 6 is also there. 3, all are. So again, R2 is a subset of. Therefore, it is a relation. Check with the third one. Four, 2 not there, no? Even if one is not there, you don't even have to check the other one. It's not a subset. If you had to do arrow diagram wise, how it would be? 4 is going to 2. 4 is going to 2. That means it would be ulta. B would be. But there is no 4 actually. It should go from here to here. So it is not possible. So that is why it is not a relation. Fourth one, A cross B. Obviously, A cross B means all the elements. So you should know. Okay, so R4. So R4 is equals to A cross. Therefore, relation. Either it can be equals to or a smaller part. So obviously, A cross B is equals to A cross B. So that is why it is a relation. Now the third one, A is given, B is given. So first you can find a Cartesian product. Third one, you can find a Cartesian product. Now find a relation where A comma B, where A is less than B. You see this symbol? A and B belongs to all the natural numbers. So A is less than B. This is A, this is B. So pick only those elements where A is smaller than B. This we cannot take because 6 is bigger than 1. So A is bigger than 1. Here also A is bigger than 1. Bigger than 1. Here, like this. No, sorry. 4, comma 8, no? And who else? A should be bigger than B. 6, comma 8 here. Only 2 elements. So your answer will be 6 and 8, 4 and 8. Only those elements where this number is bigger than this. If you see rest all, A is bigger than B. Pick only those elements. So that is how you have to find a relation. So like this, they can give you any condition and then you have to look and pick up those pairs. Now write the range, domain and codomain. I don't know how to write. First write the domain, range, then write codomain. Use curly brackets for this, huh? And don't put bracket and all, huh? Open it. 8. There's no point writing 8 again. Full set B we have to write. Codomain means. Irrespective who is connected to whom, the entire set B we have to write. Fourth one. A is given. Define a relation R on set A. Now B is not given. So in this type of cases, relation on set A only it is saying. So it is basically meaning A cross A only. Okay. B is not there. A is related to A only. When they say is related on set A, so it is basically A cross A. When there is no B present, it means it is going to be with itself. And the formula given is we have to pick those elements such that now some formula is given. So here it is A. This side also it is A only. Now, whenever they give you, this side is X and this side values are Y. All the elements which are related to A are called X, or maybe small a also they could give, and the which are connected to this. So basically this is like the input and that is like the output. So first we will see this is the main formula given. So Y is equals to X plus 1. Okay. So first value of X is how much? These are all X values. So to see when X is equals to 1, put the value of X and see of what value of Y you should get. So Y will be 2. Okay. So when X is 1, Y will be 2. Then when X is equals to 2, it will carry on. So Y like that. So when X is 3, Y will be 4. When X is 4, Y will be 5. In this formula we have to put. Now when X is 5, Y is 6, but there is no 6 there. So we can ignore. So this not to be taken. So 1 is going to 2, 2 is going to 3, 3 is going to 4, 4 is going to 5. If you go for with what is that Cartesian product also, that way also it will be done. But then you'll have to check X and Y. Y should be 1 bigger than X like that. Okay. Or this is another way directly without Cartesian also. This calculation is not required to be shown. You can just understand, then draw that. How to write the relation? So this means X comma Y. So 1 comma 2. This means 2 comma 3. This means 3 comma 4 comma 5. We cannot take this because 6 is not there. So your relation will be 1, 2, 2 and 3. That's it. Like this, they could give you any formula. You have to make sure Y is single on the left hand side, rest all is on the right. You have to start putting the values of X and then check what is the value of Y and accordingly mark the arrows. Now write a domain. I'm not asked, no? Okay. But now if domain was asked, it would be 1, 2, 3, 4. If range was asked, it would be 2, 3, 4, and 5. Do you not understand? Some difficulty. Okay. Now similar way, try the next one. Arrow diagram is not compulsory until and unless they tell. You could directly without arrow diagram 1 comma 2, 2 comma 3, 3 comma 4 also you could write. Those are done. Can try the fifth one. Same. A is now 1 to 14. Again, A is will be from 1 to 14 only because relation is from A to A. And the formula given to you all is 3x minus y. Basically, y value we have to find. So while those are already solving, take it like this. Y should be single on the left hand side, remaining you take on the right hand side. Now start putting values of x. X you put 1, calculate the value of y. X you put 2, find the value of. This done? Understood. Try the next. A is 1 to 14. So it is A cross A. And the formula given to you is, now last time y was given anyways alone on the left hand side. Now whose values we have to find? X values we know, like where the values of x is connecting when x is 1. So what will be the value of y? So if the like this also you can do when x is 1, 3 minus y equals to 0. But then every time you'll have to take it on the other side and then find out. So rather than doing that, what you do is keep y has to be single. So y is 3x. We'll use this. So when x is 1, y is how much? 3. So first one is 1 comma 3. And when x is 2, y will be 6. So 2 comma 6. Then carry on. You will know when to stop. This number should not cross 14. The moment you cross 14, it's like A to A. So 1, 2, 3, 4, 5 like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So up till 14 now they are on this. So when x was 1, y is 3. 2 3s are 6. 3 3s are 9. 4 into 3 will be 12. Now 5 into 3 will be 15, but there is no 15 to mark. They have to stop. So this will not be taken last because it has crossed 14. Now write the relation. That's it. And now fast domain, range, codomain, you can write. And codomain, you can just write A also and give, or also like this only up till 14. Entire set B. B means the output set. Codomain. Now A and B are same. Codomain will be this up till 14. Read the sixth one and try. Set of natural numbers it is. R on set of natural numbers where x belongs to natural number and x is less than 4. So x values, whatever you have to take, should be less than 4. So we have to stop at 3. X will be 1, 2, and 3. Question number 6. Define R on set N. R is given as y equals to x plus 5. X belongs to natural numbers and x less than 4. Where both x and y belong to natural numbers. Depict the relationship using roster form. Roster form in this fellow, huh? What we are writing, this is the roster form. Either you can write roster form and the arrow diagram also you could do. Find the domain and the range. So now you have to concentrate the main part with what the R is given. R given is y equals to x plus 5. Now set A, B is not given. So it is a set of natural numbers. So this would be n, this would be n. So it will keep on continuing like that. Okay. Now they have specified x is natural number and x is less than 4. So which all x values you can take? 1, 2 and 3. So we know where to stop. So only 1, 2 and 3 you have to take and see where the arrows are going. That's it. So y will be now write it in roster form, write the domain, write the range, write a codomain also. What would be the codomain in this case? Natural numbers. All. Entire set B on natural numbers. And you can write and keep. So this relation is 1, 6, 2, 7, 3, 8. Any difficulty? Did not understand? Y is given now, but there it's a natural number, so you don't know till where to continue. If this was not given, then it would keep on going like that. But now you know x, start putting the values of x and you have to stop because x is less than 4. Only those values you can take and only natural numbers you can take. So it will start from 1, 2 and 3 and then find a value. So domain will be 1, 2 and 3. Range will be 6, 7 and 8. Write a codomain also and keep. Codomain will be, either you can write directly n. N is understood, natural numbers. Or you can write 1, 2, 3, like this. Okay. Both the ways you can write. N is the better choice. And just write n and keep. N is natural numbers, it is understood. So clear? Question number 6. Now question number 7. A is given, B is given. Define a relation. Define a relation R from A to B such that the difference between X and Y is odd. So now there is no formula given. You just have to see difference in X minus Y should be odd. So you can use Cartesian product also and check. Okay. So you can find a Cartesian product between A and B and take only those pairs where if you minus both the numbers, you should get odd number. Difference between X and Y should be odd. Minus this and see. 1 minus 4 is minus 3. Well, which one? Some. Oh. Okay. Now just minus and see. Whether it is negative or positive, that doesn't matter. It should be odd. Okay. So x minus y should be odd. So alternate it will go, I think, no? No, here also. No, not alternate because those are some are even, some are odd. Okay. So this one, 1 minus 6 is 5. This is 1 minus 9 is 8. Cannot take. This is also even. If both are even, it will be even only. So pick only those numbers where one is odd and one is even. 2 minus 9 will be 7. Yeah. So write those pairs. So that is your relation. So only those pairs where x minus y is odd. If they had said even, then you have to take these pairs. So if you minus every term and see if you are getting odd or even. So those elements only. Sorry, this is R. 1 comma 6, 2 comma 9, 3 comma 4, 3 and 6, 3 and 9, 5 and 4, 5. Then according to once you get the relation, you know how to write now. Domain, range, codomain. We start somewhere. Yeah, odd and odd, sorry. So pick only those pairs where one is even, one is odd. Because even minus even will be even and odd minus odd also will be even. If without using Cartesian also, if you can directly check here also, you can do like 1 and 4, 1 and like that. Now question number 8. Arrow diagram is given. Figure shows the relationship between set P and set Q. Write the relation in roster form. So normal. Right. Roster form you write first. 5 comma 3, 6 comma 4, 7 comma 5. So arrow diagram is given. We have to write it. Domain and all is not asked. We can just write in roster form has been told. So write in roster form means this itself is roster form. Done. If domain, range and all was asked, then you have to write extra. So you can move 8th one. Try to write in the set builder form. How you'll write? You'll have to now. It's like you have to give this problem to somebody like a formula form. So right, x equals to what is the relation? There is some pattern. See, from 5 it is becoming 3. 6 it is becoming 4 and 7 is becoming 5. From every number, how much is minus 2? 2, no? 5 minus 2 will give you 3, 6. So try to make a formula. X are on this side, Y is on this side. So what minus what should give you that? So check. Try to write a general formula for that if it is possible. Whether it is Y equals to X minus 2 or X equals to Y minus 2. Check. Usually we write in Y, I told you. Y should be on the left hand side. These dots, I told you why they are there in the textbook, so that you know that this is a separate number. The first one is roster form. Second one is set builder form. So you know that 5 minus 2 is 3. Okay, 6 minus 4 is all 6 minus 2 is 4, and 7 minus 2 is 5. So y you have to write first. From x, how much you're minusing? This is the main formula. So now write. Usually we write x comma y as a pair. This is like a x. So when x is equals to 5, put 5 and see. 5 minus 2 will give you 3. Then put x equals to 6. 6 minus 2 will give you 4. So y, make sure you're keeping on the left hand side. If it was increasing, then it would be plus like that. Understood? Just see the relation. Now we have to explain the relation. So from left hand side, you minus 2, you are getting the right hand side. So we have to write it in set builder form. So how will write? Y is equals to x minus 2, where x belongs to which one? P. X belongs to P and y belongs to P. So this is called a set builder. If you want to put right comma or end, that is okay. So even if you put comma, it is fine. So where you could write small p and q also if you wanted. But then here it would look confusing to write in terms of q. Write in terms of x and y. So this is called a set builder form. Third one, write the range and domain. So domain is 5, 6, 7. And range is 3, 4, and 5. Some difficulty there? So means the condition to put that way. X belongs to natural number बरोबर पडले. Actually, although they have given like that only, but yeah, I can mention that. Yeah, but otherwise all the natural numbers will come now. No, I understood his point. What he is saying now, if you give this to somebody, now you will not know which x and y values you will give. In that case, then we'll have to P will have to write here 5, 6, and 7. Q will have to write 3, 4, and 5. Or the textbook they give this solution only, but you can mention suppose at the side. Then x would be natural number. Okay, x belongs to, and then between 5 like this. So this is what you are saying, no? You can take if you want. Although this is the correct answer, means they are expecting this, but logically, yeah, that is also correct. So those who check then in college what they do. They are giving up till here, then don't stress your head. Otherwise, you can write this also extra. If you write also this, it is not that they will cut marks, huh? So you can write it. Understood what he was asking? It's like you give this problem to somebody else to solve, and that person should know which values to take. Huh? Yeah, so the exactly. So the textbook is referring the diagram and telling. Yeah. Yeah. So then, so logic wise, suppose, see, if you know the diagram only, then there's no point writing in set builder form also like that. So Both the ways are correct, so it's fine. So this what they are expecting is only for your diagram point of view, if given the diagram. Some. Okay. The ninth one, A is 1, 2, 3, 4, 5, and 6. R would be B is exactly divisible by A. Now your Cartesian product would look like this. That is also this. So 1, comma 1, 1, comma 2, 1. Yeah, 36 pairs. So not required 2, comma 1, then 3, comma 1, like that. And last would be 6, comma 6. So if you are like struggling with that part, normal, like if you cannot imagine, then you have to write all the 36 pairs. Otherwise, what they are saying is B upon A, okay, should not be a fraction. B should get, B is exactly divisible by A, okay. So equals to no fraction you should get. Now first one, 1 upon 1, it is divisible, correct? What is 1 upon 1? 1, you're not getting a fraction. So you can take that. Now 2 upon 1, B upon A. So 2 upon 1 is 2. So that is also working. Then 3 upon 1. So keep on looking at the next pair, 1 and 5, 1 and 6. Now, when you go to write 2 and 1, next you know that your range will start, this pair will start from 2. 1 upon 2, is it going to work? No, so you don't write it. Then you know 2 and 2, yes, it will work. So like this directly also you can do. Otherwise, if it's difficult for you to imagine, write all the 36 pairs and check 1 upon 2, not possible. 1 upon, like that, 2 upon 2, either way. So write the answer basically. So here you is to write the relation. Understood? Second number upon first you have to do and see. If you are not getting a fraction, you have to take that. If you are getting a fraction, don't consider that in the R. Huh? Yeah, first you write a relation, then the linear domain and range. So you cannot jump from here to there. If that said A is exactly divisible by B, then you have to try ulta. Then this would not work. Then you would get 1 upon 2. So check the letters and do. Right. Complete. Complete the relation. Yours is started. College started with the chapter. Only one teacher is teaching. Two. The other one, trigonometry. This only. And the first and the second chapter as well. Two comma 3 I cannot take. Why? 3 upon 2 will be a fraction. Decimal points you should not get. Then 2 and 4. Yes. 2 and 5 will not work. 2 and 6 will work. 6 upon 2. So you are done with 2 parts. Then 3 and 1, no. 3 and 2, no. 3 and 3. 3 and 6. Then 4 and 4 straight away. Then only 5 and 5, 6. Rest all numbers, if you try, they will not get divided. So rather than writing the 36 pairs, if you can directly check here, you can try 4 and 5. No, because 5 upon 4 will get. Second upon first you have to do it. And then write the domain and range. Anyone who did not understand this? 1. So there's no point writing 1 6 times. All are there. And range also, I think all, no? 1, 2, 3. Huh? 1, 10 times you'll write domain. Huh? What are you saying? Ah. No, I'm sometimes thinking I made a mistake, or you're correcting me, or you're telling me. Okay. Now to the next one. Determine the domain and range means first you'll have to find a relation. X comma X plus 5 is given. So basically X comma Y it is, no? So Y value is given as X plus 5. So Y equals to X plus 5 we have to take for the next problem. See, it is given like this. So you know this is your X, this is your Y. So and which all X values you have to take? 0, 1, 2, 3, 4, and 5. So once you put 0, 1, you put 1, 2, 3, and find the values of Y. So then you will get the relation. So these are the various ways you can get. So even if you get like this, then you know Y should be equals to X plus 5. Now this is X, this is Y. So this is the formula. So put X equals to 0 first. So once you know that other ones also. So Y will be 6. X is 2, Y will be 7. So straight away also you can write the relation. Last number to put is 5 because they have given in the question the values of X to be taken as 0, 1, 2, 3, 4, and 5. Now write the relation. Don't forget to write like this, a roster form. Even if they don't mention, you have to write in roster form and keep. We have understood the 10th one, 11th one you try on your own. Now consider if this had come for your exams. Now you would solve this. X comma X cube, where X is a prime number less than 10. So try this and write. Try that. So what will be y? Y will be x cube. Comparing x comma x cube. So y will be x cube. So take all the prime numbers which are less than 10. So which are prime numbers? 2, 3, 5, 7. So cube and right. So 2 comma 8 it will be 2 cube will be 8. And find 3 cube. Find 5 cube and find 7 cube. Seven into 7 into 7. No, 243, no? 3 4. 729 is better. 3 raised to 7. 3 raised. Okay. One more time if you multiply, I think. No, something will be. That is 9 cube, I think. 720. Okay. So write in the roster form and keep. The 12th one. Find a number of relations from A to B. How many relations are possible? Okay, so relations are nothing but like all possible pairs which you connect, like kind of the Cartesian product only. So 2 raised to, it would be 6 or m into n. So you can write a formula also and keep, because A cross B will have m into n. So those number pair will be all relations possible will be can write this formula. Then calculate. All the possible subsets of the Cartesian product. Because relation, what is the definition? Relation says it is the subset of your Cartesian product. So Cartesian product will have how many elements? 6 elements. So 2 raised to 6 will be all the possible subsets. 2, 4, 8, 16, 30. 4, 32 it is, or 64 it is 64. 2 raised to 5 will be this 32. 2 raised to 6 will be 64. So these are the possible relations. Okay. Then 13th one, let R be defined on Z as R is given as something A comma B, where A comma belongs to Z. Z means what? Integers. And then write A minus B is an integer. Here we have to write only the domain and range. We cannot find actually the relation because integers are too many of them. Okay. All the integers. So they are not specified where exactly. So you know that only integer minus integer will give you integer. So the domain and range. So if all integers you take this side, 0, -1, -3, -5, whatever, 1, 2, 3, 4, 5, like this. This side also, if you take integer, -1, -2, you know, all will work, correct? Integer minus integer will always give you integer. There's no option only that will get a fraction and any number will get discarded. So every arrow will go to somebody or the other. So domain will also be integer and range also will be an integer. Because 1 minus 1 also will be an integer, 1 minus 2 will also be an integer, 1 minus 3 also. So it is going to work with all the numbers. Because integer minus integer will obviously give you integer one. So there is no way that any number will be left out without an arrow. So that is why straight away domain is Z, range is also Z. This too, we have learned in the sets formula, number of subsets possible is always 2 raised to n. This is a fixed formula which we have learned under sets chapter. Now, how many relations possible? Relations are nothing but subsets. Whose subsets? Cartesian product subset. So how many will be there in A cross B? 6. So one will be like empty, one will be like 1, those. So it is not possible like to try all elements with 6 of them. So the shortcut formula is 2 raised to n. In power set, how we are done. Same platform. So you have to remember that formula in that sets chapter also. Under power set, we had learned it. Next, inverse relation. This they might, some of them might not do also. I think it's not there in the textbook. But it is simple. Inverse means ulta, you have to make it right. I straight away give you this. R is, I'm not stressing much on this because it is not there in the textbook. I think one of the college was doing that. And we don't have presentation. I think in their school, college, somewhere they had done. That is why I had included that, just to know. R is given. Find R inverse. Inverse means ulta you have to make. Just make the pair opposite and right. As simple as that. Eight comma 2. So you'll have to write it as 2, 8. 9, 7. 1, 2. 6, 3. 8, this is an inverse relation. Now, domain of R inverse will be ulta, which was the range of this fellow. So exchange it will be. So 2, 9, 1, 6, and 8. And range of range inverse will be R inverse 8, 7, 2. So inverse relation basically means ulta. A is going from B, then it will be B to reverse. So we'll stop here. So functions, we can do it in the next class. We are done with the relations part. So these are all the possible ways the question can come. So not necessary now that same formula y equals to x plus 5 can come. It can be prime number, some square, anything like this. So as long as you know now how to solve them. Okay. So practice questions, solutions I will send. Okay. So you can try then till question number 13. Till question number 13. Page 18, question number 13.